the Pioneer Spec-4. Many of you who are into audio are aware of the Pioneer Spec series, and this is something I've wanted for a really long time. These don't come up very often, and when they do, they're either in bad shape like this one, or they're really expensive. So I've wanted one of these for a long time, and I have. Of course, we did a video earlier of the Spec-1 preamp, and I have another one of those yet to do in this series. I also have the CTF 1250 tape deck, which, while it's not the greatest tape deck ever made, they sure are nice looking. And of course, I have the TX 9800. So I have a pretty nice spec system, and all it needs is the amplifier. So even though this one looks to be very rough and is going to need a lot of cosmetic work along with the electronic work, it's worth it to me because this is one that I want for my personal collection. So if you care to join me in my journey here, I'm going to spend the next several videos completely, at least attempting to restore this back to its former glory. Now, just looking inside, you can see how much rust just the transformer bells have. The chassis, I don't see any rust on it, but of course I haven't had the covers off yet. Of course, the covers are going to need to be stripped and painted. They're in pretty bad shape. Back of the amp's not too bad. Nothing's broken off. I'm going to need maybe a new power cord. The input jacks are still pretty shiny, and the speaker terminals are still seem to be intact. So overall, I think we do have something to work with. Let's get the cover off and see what the inside looks like on the top. Okay, all the screws are out of the top, and I thought I would turn the camera on so we can open this for the first time together. Okay. Well, it appears that it's all here. And like I said, lots of rust on the transformers. The rest of it doesn't look too bad. I think we'll be able to work with this. Now again, I'm not real concerned about, there's really only two things I want to see in here. I want, number one, I'm hoping the circuit boards are physically in good condition. The components on them don't matter. I can replace those. And I want to make sure that both of the transformers are good. This is a dual power supply unit. So it has one independent power supply for the left channel and one for the right. And look how big those transformers are. I mean, great big massive transformer just for a 150 watt single channel monoblock. And the massive 22,000 microfarad capacitors, and there's 4 of them in there. So this thing should be really good sounding. Now, there is a larger model than this called the Spec-2, and I believe it's somewhere around 300 watts per channel. It's pretty much double the power of this, but it's not as refined of a design. It's really designed to be a big powerhouse. Some of the features of this amplifier in its design make it actually a more suitable amplifier for home use, for listening to audio at home. And that's why it's a little, most people will say that this is a little better performing amplifier from a sound standpoint rather than just volume. And that's why this is the one I really wanted to get my hands on. So let's flip it over, let's look underneath, and hopefully it's going to be clean under there. But I don't see any signs that anybody worked on the top part, but we'll see as we go along. All right, so underneath, so far, this looks really clean. And you can see the meter board and so forth. The metering circuit on this is not like the metering circuit on some of the other ones that we've worked on in the past. This one actually can show you the actual power. So we'll get more into that later. But it's a pretty complicated meter circuit. So here's your power supply down here, and then here's the 2 amplifier modules, which are really nice. They just come out, your typical Pioneer design. Should be easy to work on. And I'm going to take this all down. I'm going to take everything out, take it all the way down to the bare chassis, and restore it from the ground up. Okay, I have the amplifier ready to plug in for the first time. I had to install a fuse. There was a fuse missing. It's a 12 amp. I have one 12 amp fuse left. So I put it in there. It's the only one I have, so we're going to be careful. And what I did was I disconnected the power leads from the amplifier because I don't want any of the I don't want the power to be connected to this in case something's shorted. I just want to power up the power supplies and nothing else for beginners or for starters here. And then we'll go from there and see if how everything works out. All right, I'm going to start out with the smallest bulb in there, the 40 watt, and it may or may not let this come up, and I'll show you why. This has a kind of an interesting soft start circuit. In most amplifiers that are big like this, that have some sort of a slow start for the cap bank, they'll put a resistor in line with the transformer in the mains, and then a relay will will bypass that resistor after a short period of time, after the inrush current charges the capacitors a little bit, and it just limits the inrush current so you don't blow your circuit breaker and trash your switch and everything. This one's a little different. When you turn the power switch on right here, you can see what it does is it directly powers this amplifier or this transformer first. And then once the inrush current drops a little bit, enough for your 120 to come up, then this relay can pull in, and when it pulls in, it brings in the second transformer and charges the second cap bank for the other channel. Now I don't like that because you still have your full inrush current here, and you have two 22,000 microfarad capacitors that you're charging up all at once. So I will modify this with a different soft start circuit later on, but for the time being we're just going to leave it alone. And you can see you have two 8 amp fuses, I believe is what those are, and then there's one big 12 amp, but they're not showing right here that I see at the moment, that for your power selection and everything. And this might be a little bit different layout. I know there's a European, I think, and a United States version. This one says 120 volts, 60 hertz, so this should be the correct one. But anyway, I have the fuse was missing at the input, so I had to replace it. All right, let's turn this on. So what will happen is, if this draws too much current, it's never going to let the voltage get high enough for this relay to pull in, and it'll just sit there and chatter. So I don't know if it's going to do that or not. Even with all the, everything disconnected, it still might be too much, and we may have to go to a little bit bigger bulb. But let's see what happens. Here we go. Oh, not happy. Just like I thought. Okay, so there's just not enough current to let that relay pull in. So let me go one more bulb, and if this doesn't do it, there's something more wrong than just that, because I don't have anything with big current connected. If you saw, we disconnected the power from all this. All right, let's try it one more time, and this is it. Nope, that's not right. Okay, as it turns out, I just didn't leave the bulb on long enough because it has to, those caps are that big. So let's try this again. Now it's charging up, and see how dim the bulb went? Both sets of caps are now charged, I believe. Let's see. So, okay. So let's go on the common down here, and we'll go to the positive voltage. We have positive 56. Negative 56. That's good. Go up to this side. We have positive 57 Negative 57. Excellent. Let's turn this back off. So the good news is the power supply is good, at least that big power supply. We don't know if the regulated power supply is good or not, but we don't have any shorts there or anything. Now the next thing we can do is we can connect this back up and see if the amplifier modules come on, but we'll probably do a couple of static checks before we do anything else. I want to make sure, I don't want to cause any damage in here if there isn't already damage on it. Who knows? I know nothing about this amp. I don't know if it worked. I just know that I'm going to be really careful. Now the next thing we have to do is make this safe to work on. We do have plus and minus almost 60 volts, and of course the difference between that's 120 volts. So from the orange to the red is going to be 120 volts. Now normally I would use my Stinger cable, but that resistor, that's a great big load that you have to discharge with these 22,000 microfarad caps. So what I do is I have a rough service appliance type bulb, and it's only like 25 watts, but it's good for 125 volts. So what this is going to do is going to get super bright, but it will discharge the capacitor safely, and it won't overheat like that resistor and blow open. So let's do that first. You can see it just gets a little glow and then it goes out. So that's discharged. Then we go to this side. Same thing. I don't know if the camera's even picking the bulb up. Then I go over to this side and we do from here to here. And we go from here to here. Then I go from here to here. And then I go from here to here. And everything's good. So now the amplifier is safe to work on. Now for one last thing, we want to just make sure of that. And you can see 100 millivolts, 300 millivolts. Let's see if I can keep out of the way so you can see 1.4 volts, 0.4 volts. So everything is very low and we're safe to work on. Okay, so I'm just going to do some static checks of the power supply, where the power supply goes into the amp modules. And the first thing I'm going to do is I'll put my probe on the ground, and I'll just go from ground to the negative lead. And I'm on the 100K times 100K. The reason I'm using that is because there's a 30 volt battery in this, and it uses a 30 volt power source for this, so it can kind of overcome some things that your little digital meter cannot. So I kind of like using it for things like this. And I'm just looking to see where we are, and I'm going to compare the two channels. So you can see from there to there I'm reading something. From here to negative to positive I'm reading nothing. If I switch the leads around, I read that way. So I read this way in this direction, and I read this way in this direction. And I don't read anything in this direction, and I don't read anything in this direction. So keep that in mind. We're going to do this on the other channel. So already that's different. And if I reverse the leads, I'm reading in both directions. And then if I go here, see that? These two channels are different. It tells me that one of the channels has a problem. And good thing we didn't try to power it up. Now you notice there was no dead short on there. Let's just try using a regular voltmeter and just my fluke meter, and let's see if we can get the same results if we go to ohms on this. Okay. So 2 mega ohms, 2 mega ohms, so it reads the same in both ways. Now if I go this way, 2 mega ohms, 2 mega ohms, so it doesn't really care. And it's reading mega ohms. If I go this way, 3 mega ohms, 400 mega ohms. So you can see how hard it is to read with this digital meter. Whereas that one with the 30 volt supply makes a big difference. And that's kind of why it's still good to have an old-fashioned meter around. These analog meters, one thing that they do that's good about them is they do have a lot more current with your test voltage on the ohms mode. Now you got to watch, because if you're testing very sensitive electronics, that can be a bad thing. But when you're working with things like this, that actually is very helpful, and that's why I always keep one around. Now, why did I test things the way that I did? Well, from my perspective, what I'm concerned about is if this is a candidate for rebuilding, I have to have good transformers. They have to be able to produce the power to power up the power supply. If one of these were bad, that would be a showstopper for right now, because these are going to be very, very hard to replace. Whereas anything else in here, you can pretty much, other than the circuit boards themselves, and even in a pinch, you could do something about that. Everything else in here is obtainable. This, not so much. So I have good transformers. I know I'm going to make this thing work. So now that we know all of that, I'm going to pull each module out. I'm going to completely unwire it and remove them, get them out on the bench. I'm then going to remove this chassis. This is a separate chassis, the whole power supply. And we can just remove this as one big chunk and put it on the bench and rebuild it. By the time we're done, we will have nothing but the individual metal parts of the chassis, and that's it, and everything else will be separate. So next time you see this, it will be in a million pieces. Okay, the disassembly is done, and I definitely smell rogue electron farts on here, and I see a couple of skid marks. So I think it's safe to say there's some things shorted out. But anyway, I'm going to start the process of cleaning and, testing and rebuilding and all that. And we'll go through this a little bit at a time. Okay, I believe this is the latest version of this thing. And the reason I say that is this has 2 soft start relays instead of 1. It also has an extra set of wires coming out of each transformer. There is a set of purple wires, or violet, whatever you want to call them, and a set of orange wires. And those are actually thermal fuses. And if you recall from my, the Kenwood KA9100, those are those little thermal fuses that are inside the windings that if the transformer overheats, the fuse will open up and it will open the circuit. So this is one of the later versions. The other thing is, on all of these, as I said before, the transformers do not match. One of them has an extra winding. Now, here is the schematic as you download it, and it has this little power supply. And this is a more simple version that uses just, and if you look at the theory of operation, they tell you there's 2 fuses in there instead of the one 12 amp fuse. And these are wired in parallel. It's very simple. It's only a single voltage, so it's not a multi-voltage unit like this one. This one has the voltage select control. And much more complex on this one. You can see you have your voltage select switch. You have 2 relays, and each relay has 2 sets of contacts. So it's kind of convoluted the way they're doing this. But And like I said, I'm probably going to modify this so that we don't have this anymore, but I'm not sure yet. I'm going to check these relays first of all. If they're in perfect condition, maybe I'll leave sleeping dogs lie, but if not, I'm going to modify this a little bit, make it a little more reliable. The more relay contacts you have, the more occasion you have of a relay failing. So that's kind of why I try to do things in a way that'll last as long as possible. So I'll try to highlight some of these lines so you can see where they're going. And I'll wire it for 120 volts and kind of draw it out that way. And then we can take a look at what's going on. Well, I'm kind of glad I took the time to reverse engineer this so I could see just how convoluted this was. So on the multi-voltage version, it's a lot more complicated than the simple, you know, the one that's just sold here in the States. So you can see you have this coil in parallel with this here. You have your 120 volts going in. There's a little delay before this pulls in, so that allows this transformer to start up just before this one, so you don't have both inrush current of both transformers hitting at the same time. But I would still argue that's still a pretty heavy inrush current because, again, there's nothing limiting the current for this transformer to charge up this huge capacitor bank. So you really need a better soft start circuit than this. It's just not what I like. Now you look at this one, and rather than making a couple small changes, they just went crazy on this. So you see you have this little unit. This is that round thing right here that allows you to select the different voltages. So, you know, by pulling this out and rotating it to whatever voltage, inside here are contacts, just like switches. And depending on how you have them, so this is 110 volts, this position, this top one, and this is 120. This is 220 and 240. So depending on what your mains voltage is, that's how you would arrange this. So we have 120 volts here in the United States, so this would be connected to here, to here, to here, and to here. So you notice these two right here have no connection. And it took me a minute to look at this. So you have two separate transformers, and they are wired in parallel. And what they're doing is, because you have a separate tap for 110 and for 120, they had to accommodate for that by putting a relay on. Pretty much they just put relay contacts on everything. So this one, when you have 120 volts, this relay contact is doing nothing. It's connecting these two leads together like that. But even though they're connected in parallel, they're really not, there's no current flowing through here. Nothing. Because this is not connected to anything. So essentially these two taps are kind of just floating, even though they're tied together. Same thing here. You have this one going down to this one. See how they're tied together? They're in parallel. And so, and you can see it's switched as well. So depending on if you have it on 110 volts or 120 volts, it depends on which set of contacts is actually going to be switching the voltage on and off to the transformer. So it's, like I said, it's kind of convoluted. Now if you redraw this just wired for 120 only, it looks something like this. Much simpler. And this is really all they're doing, is they're switching both sides of the mains instead of just one side like you would on this simpler version. They're actually switching both leads. Okay, that's what this is. And here's your relay, and it's still just shunted right across your mains. So you can see your mains voltage here, comes down into here. This is across it. So what happens is when you turn the power on here, this will come on right away. And then after a slight delay, while this energizes and pulls in, then this one will pull in. So that ensures that these things aren't starting up on the same cycle, okay? Because this probably takes about 8 milliseconds to pull in, whereas this will start right away. So you'll have about 1 or 2 cycles, about 1 cycle or half a cycle before this one pulls in. So you're still putting a lot of inrush current in this thing doing it this way. So this is not a very good solution for a soft start circuit. Now that other relay, the reason there's a second one here is they put this same set of relays here and here. So this one is tied to here and this one is tied to down here. And then they put a relay like this on it, on both of these, so that if you have this thing jumpered for 110 volts, it switches this on and off instead of this one. And then this one becomes not connected to anything. Weird. Wouldn't it be easier to just direct wire these like this and then have one of those little soft start modules I made that works off of the capacitor charging level on this one and one of them on this one? And each one can soft start individually. It doesn't matter, one has nothing to do with the other, and when this cap bank gets up to a certain amount, the relay will bypass the soft start resistor, and the same goes for here. So that's what I'm going to do. I'm going to wire it for that and get rid of all this. In addition, these contacts are kind of, you can kind of see this. See how that is? I'm not worried about it because I'm not going to use these. But they're a little bit tarnished. They're not bad and they're not pitted or anything like that. But again, I'm going to put a better solution in here than that. Okay, here is how we're going to do this. So the first thing I'm going to do is I'm going to take this red wire off of this relay. And you can see the red wires are right here. These are the 110 volt taps. And you see they're tied together, and they are tied together between here and here. You can see it. So what I need to do is there's a jumper. See, there's 2 on this. These 2 posts are tied common, and these 2 posts are tied common to one another, the red posts and the yellow posts. So what I'm going to do is I'm going to remove both of these red wires off of this relay. And one of them is just a jumper going over to here. And I'm going to remove that jumper. Then I'm going to take this wire off that's coming from the transformer and connect it over to here. So that's going to get rid of this. Then I'll do the same thing with the yellow. I'll remove the yellow jumper, which is this one right here. You can see. I'll remove that jumper, take this yellow wire off, and connect it to here. So that's essentially all I'm doing, is just bypassing these relay contacts. Then the green and the gray, I will just remove this gray wire and I'll attach it right here where this green wire is, just straight on. And you can see that gray and this gray will go together because, again, these 2 leads are tied together. Then I'll do the same thing with the white lead. I'll take the white jumper off and take this white lead from this transformer and move it over to here. So then everything will then be wired, and these brown and white wires can just be removed totally because they're just used to power the coils of the relays. So those will all be gone. Once we get that in place, then I will take the common lead of each one of these transformers, which will be, in this case, it will be the connection where the white lead and the gray lead connect together, and where the white lead and the gray lead connect together here. And actually in this one, yeah, we're putting these these two are ending up being together. By putting these two coils in parallel, we're wiring it for 120 or 110. By putting them in series, you're wiring it for 220 and 240. So I hope you understand what that is. So in other words, if I disconnected these from being in parallel and I connected here to here, and then I connected my mains between here and here, that would be 240 volts. And if I jumpered these two together and disconnected this one and go from here to here and here to here, then I would have 220 volts. Does that make sense? So basically, you're either putting the coils in parallel or you're putting them in series to get the different voltages. That's all this thing's doing. But if we eliminate all of this, then we can actually put our soft start circuit back in here somewhere before all of this mess. I'm just going to do the soft start right onto the common lead that goes out to each one. So it'll make more sense once I get it wired up, and you'll see it. That looks a lot neater. So now I have to make one other change, which I've already made, and I'll show it to you here in a minute. And since we have this particular unit, you notice you have two thermal fuses, one in each transformer. One of them has a set of purple wires, and one of them has a set of orange wires. And one end of each of one of these ties together. You can see kind of it's in a loop. So you have just one big long series circuit, and it goes from this end of your AC mains up through the one end of the fuse, out the other end, around, down through this end of the fuse, and then back to this end. So it's essentially connecting this circuit right here. So over here where these two wires connect, this orange and this purple right here where they connect together, I've separated it. And if you look down here, here was the purple wire, and it was originally connected onto this orange terminal, and this terminal was empty. I moved it over to here, and then as you can see, I added two auxiliary wires, and they're going out through this hole down here. And they're going to wire into these two modules, which when I'm finished with them, they are going to be the new soft start circuit. Now I have to get a couple of components for them. I also ordered new filter capacitors and everything, and when those come in another day or so, we'll complete that. Now while I'm waiting for the rest of the components to come in for this, I'm going to clean these off really well. And I'm just going to take some enamel and repaint just the top part of the bells here. As you can see, the bottom part is in really nice condition on both of them. So they just need to be cleaned off, but I'll just paint these tops. I'm going to remove these capacitors and kind of get things ready to clean the chassis. The new soft start modules are going to mount over here, and they'll be stacked on top of one another. And again, I can't do any of that until some parts come in, so I'm going to call this part 1, and I'm going to get this edited and posted up. And when parts come in and I get back to work on this, I'll be back with part 2. So until then, as always, I wish you all peace, joy, happiness, and good health in your lives. And I'm really excited to see how this thing turns out. Stay well, everybody. Bye-bye.